All right, now, I want to look at water and why water behaves like it does in a solid state. Is the density of water heavier? Is it more dense or less dense than ice?
Density of water.
Yeah, the density of liquid H2O. Is it more dense or less dense than ice?
No, it's more. It's more dense. More dense. After it goes below 4 degrees, it's less, like in a solid state. The water is less dense.
Right. The density of water decreases as it cools. So Enzo's right. It decreases as it cools. So it goes from 20 degrees to 19, 18, 17, 16, 15, 14, 13, 12. Right? It keeps decreasing, gets more and more dense. It hits 4 degrees, and then it starts to get less dense.
Oh yeah, that's what you told us about.
Yeah, that's
4 degrees.
Yeah, see? What is the temperature right now of the water at the bottom of Lake Baikal in Siberia, which is approximately a mile deep?
4 degrees.
4 degrees Celsius.
I have another question.
Yes?
At the bottom of the Pacific Ocean, is it also 4 degrees Celsius?
Yeah, it's probably a little colder than that because it's salty, but by and large, it's the temperature of all water, okay, that's at the bottom of a large body is going to be 4 degrees Celsius, okay? Just the way it is. Yes? Okay. So we're ignoring freezing point depression, we're ignoring the effect of dissolved solutes, but we're saying, and this is why. Now the book looks at it like this. The book looks at it very much two-dimensional, like this. In other words, it says that water forms this hexagonal ring, right? Doesn't it say that? Six-sided ring. I drew it very poorly. What are at the corners of the ring?
There, yeah.
Excuse me for a second. So it looks like there's one hydrogen. Okay.
In the
Yeah, so it's going to look like this. So you're going to have, can I see that book for a second? Could you hand it to me, please? According to the book says it's going to look like this. The book says that a water molecule, it's going to form like this. It's going to form like this, where this is oxygen, this is hydrogen, correct? And then you're going to form it like this, where this is hydrogen. No, this is oxygen. This is oxygen. And this is hydrogen, right? And then you're going to form another one like this, right? Where this is going to be oxygen here, and this is hydrogen. Then that's going to be 1, 2, then 3. Then this is going to be formed like this, right? That's hydrogen, that's oxygen. And then you're going to form like this. This is oxygen, hydrogen. And then you're going to form like this. So that's 1, 2, 3, 4, 5. I'm drawing it very poorly. Okay? But the idea is, I'm going to have to work on that drawing. But the idea is like this. This is going to be oxygen, hydrogen, oxygen, hydrogen, oxygen, hydrogen. Correct? That's what it says, right? And that these bonds here are what?
Yeah.
What are those bonds there? What are they called? Who said that? Yes. These are called hydrogen bonding. H bonds. But it's a little bit misleading because things don't form like that because water forms two-dimensional. So this is how it, I think it's a better drawing in some ways, correct? Yes? Where remember you have carbon and you have these 4 bonds. Let's say we have this, okay? So you have this tetrahedral formation in carbon, and when carbon bonds with itself, it forms a crystal called diamond, correct? Because you have this 109.5 bond angle within the carbon. But if you replace this with oxygen, if you replace this with oxygen and call this hydrogen, hydrogen, and call this, we'll call this partial charge, okay? So that these are chemical bonds, and these are physical bonds called hydrogen bonding. So when you have water forming, ice, when they line up, okay, when they line up, these two form physical bonds, and these two form physical bonds. So you're forming H bonds here, correct? Yes? So I'm forming 2 hydrogen bonds here, and then I have my regular bonds here. So I have 2 regular covalent bonds and 2 H bonds in every molecule of water. Do you see that? I'm going to come back and do H bonding part 2, and I'm going to use some clay. Clear? Be right back.